welcome to the part 2 video of interval notation. I'll carry on from where I ended, as a lot of people have requested that I complete the lesson. Okay, I thought that if I just record the first lesson, people will be understanding, but I've figured out that the majority are still getting stuck on solving questions like this. Okay, so here we have a question. They're saying that let A be equal to this interval and be the universal. So A is the universal set, and they're saying that, and X is having this interval, Y is having this interval, and Z is having this interval. They want us to find each of the following sets and display it on the number line. So this video is the continuation of the previous video. This is a part 1 video. That's where I'll carry on. In this video, I won't focus much on the basics because I already explained all that in the part 1 video. So if you want to follow along this video, make sure that you watch part 1 and make sure that you're comfortable with everything that I solved in part 1 because I explained in depth and in simple terms. Okay, so right now I'm just carrying on from where I ended from, and these questions are the last question that I should solve because they rarely go beyond this. I know that in the tutorial you might find something that is even beyond what I'm just gonna solve right now, but on exams and tests they don't reach that far unless maybe it just happened for the first time, but it has never happened. Okay, so I will solve these questions. Let me even proceed. I don't need to explain much. I've already explained like a lot of stuff in the first video, the part 1. Okay, so they want us to first find A minus X. Now, how do you do this? How do you solve this? Okay, so let's solve A minus B. So according to De Morgan's laws, if you have A minus X is same as having A intersection X complement. Okay, they want you to find everything that is in this one but not in this one. Okay, so the way that you do this is that first you're going to draw the number line. I'm going to use a freehand, but you have to draw it very neat using a rule. Okay, so you have a line like this. Like I've said, it's not going to be very neat. So here's like you have a 0. Okay, so you're going to put this. First, you're going to begin by plotting A on the number line. Okay, so A, you have first you're going to look at what numbers do I have. You have -9 and you have -1. So on the negative side, you're just going to have -1 and -9. Okay, and then now you're going to look on the other side. You're going to check that, okay, which positive numbers do I have? You have 7 and you have 8. You have 9. You don't necessarily have to show from 1, 2, 3, 4. Just write the numbers that you have been given. Okay, your lecturer will still mark you. Now you need to show A on the number line. So A is starting from let me just put this on A. Okay, this one. Okay, you have this. So A is starting from -9 A. Okay, you draw a circle which is a bubble. We call this a bubble, and it is going to 9. Okay, +9. So our A is this one A. So the elements, the numbers that are found in A are from -9 to +9. So on this range A. Okay. Now since A at -9 A, you're going to ask yourself, am I having a parenthesis or am I having this one? You're having a parenthesis, right? So you don't have to shade, meaning that 9 is not part of the set. Even A, let me just confirm. Yeah, so even if you won't shade, you just write like this because there is a parenthesis, not this one. If there was this A, you would have shaded. Now let's go to our X. X is starting from -1, and it is going up to I think X here where I've put 7, there should be 5. So here they're supposed to be 5. Okay, so X is starting from -1 to 5. Okay, so you're going to say that, okay, so it's starting from A, going up to where? Going up to 5A. Okay, so this is the region for X. Okay. Now you want shade. If you want, you can even label this. So this one is for A, this one is for X. Now they want us to find a region where you're going to have A intersection of X complement. Okay. So now here's what you do. You're going to ask yourself, okay, I have my XA. Where is X complement? X complement, when they say complement, they mean those the region where you can find the numbers that are not part of X. X is starting from A to A. So anything that is between this distance from A to A, from -1 to 5, it is found in X. But anything that is not in between, it is not part of X. So anything that is not in between is the complement of X. So where can you find that? Like I said, if you have a complement, you have to start from you have to proceed from where your set is. In our case, X is starting from here, so you're going to add another bubble, and then you're going to say, okay, what is not found in X is whatever is starting from here going to this side, and also whatever is starting from here and going to the other side. Okay, so now you're going to start from here and draw like an arrow, like, okay, even here you're going to draw another bubble and then draw an arrow like. Now, like I said, if you're dealing with the complement, then you're starting from an already plotted set. If you put a bubble on top of another bubble, it should be different. If this one was shaded, it shouldn't be shaded. If it wasn't shaded, it should be shaded. Now in our case, initially this is not shaded because of having a parenthesis. So now for you're going to shade it. Okay, even here you're going to do the same thing, like okay, this is not shaded, I am going to shade it. Okay, so now anything starting from here going this side, it is not part of X, but this is part of X, but starting from here again is not part of X. Now always remember this: if you have a universal set in the question, if you have a universal set, meaning that it means that whatever it will be going, it will be ending to where the universal set is starting from. Okay, in our case, it's starting from -9. So the complement of X is starting from A up to A. If there was no universal set, it would have gone to the infinity. Okay, even A, it is going to end up to A. If there wasn't a universal set, if they didn't say that A is a universal set, just know that we would have gone to the infinity. Okay, so we've now found the regions where we have X component. Okay, so X component is starting from A to A to A. So now they want you now to unite the region that you've just found, which is this one and this one. They want you to unite it with set A. Okay, I mean, they want you to not unite it. They want you to find the intersection. They want you to mention those numbers or the region that you are going to have if you were to intersect the complements. Actually, let me even label this part. I'll say X complement. Even here, I'll say X complement. Okay, so now you've managed to find your X complement, which are these regions and these regions. So now, where can you find the numbers that are found both in A, which is starting from A up to A, and they are also found in the X complement? Where? Let's begin. Where can I find the numbers which are found in this region of X complement, but they are also found in A? A is covering everything. So whatever is in X complement, it is also in A. Okay, even on this side, whatever is in this complement of X, this region, it is also in A because it is part of A. A is covering everything. So you can begin by saying, okay, so whatever is A, it is found in the X complement, but it is also in the set A. So you're just going to say that, okay, so here the answer you're going to say A. You're going to say, so first of all, I'm going to start from this side. I have starting from -9, so you're going to say -9. Remember, there's no bubble E. You're going to say -9, comma, up to A, right? That is the first region. Okay, so you're going to say, remember it is shaded, so you're going to, and what is on this bubble? It is 1, so you're going to write 1. How is the bubble shaded, right? So this time it will be a square bracket. Now you're going to unite. There are two sides. There are two regions. There is this region. You've just represented one region, where this is being determined. Okay, and then now you're going to unite. You're going to unite now. Okay, where else can I find the elements that are found in the complement of this x complement that is on this side, but they are also found in A. A is still covering everything, so it is this region A, this region A. Even A, it is on this region. Okay, I've just described this region. The description of this region is what I've written A. So even A, I'm going to describe this region A. How can I describe this region? This region, I'm going to say that, okay, apart from this region now, that's why I'm saying you are like combining them. You're putting them together. So now you're going to say that, okay, even this region, how can you describe this region? It is starting from what? From 5, right? So you're going to say that 5. Now 5A, this time 5, it has been shaded. Okay, so you're going to say that 5, meaning that it will be now part of the set, comma, and E, where there is 9, up to 9. Okay, so you're going to say 9, positive 9. This is where you can find what is found in set A, and it is found in the second x complement. There are two x complement right now. Okay, and this is how you can combine them instead of splitting them. You've given your final answer. Now, if in the question they didn't give you a universal set, there will be cases where there is no universal set. There is a tricky part. I think in the first video I said this is where most of the students get confused. So if they don't include a universal set, just know that where I'm putting negative 9A, put infinity, because it will be going to the infinity. A universal set will give like, this is where the limit where the numbers are ending. They are not going beyond this. They are not going beyond this. They are not reaching negative 10A. Okay? Even if they are not reaching 10A, they are just ending up to A. But if they didn't say universal set, it would have been A negative infinity, comma, negative 1. Okay? Union 5, even A positive infinity. Like this. If they didn't give you a universal set, you would have written like this. Now I'm pretty sure I've explained everything. Just rewatch the video, everything will make sense. So this is how you represent the work. This is your final answer. Let's solve now the second question. Okay guys, so now let us solve this one here. Okay, question 2. So we've been given x intersection z complement. So every time you see equation being phrased like this, it can be maybe either it can be intersection or union. You use the same approach that I will use. So I'm pretty sure by now you know how to plot this alone, what is inside. So you do it step by step. Okay, that's the secret about such questions. You need to be moving step by step. Don't just try to show everything at once or try to expand by multiplying this with what is inside. You just confuse yourself. So move step by step. So first you're going to show a number line that will represent x intersection z. Okay, in short, you're going to find the interval of this one A. Then after you find that interval, now you're going to find its complement. Okay, now the complement of x intersection z. Let me just show you what I'm talking about. So first you're going to draw a number line. Okay, but you should make sure that you draw a very neat one. So here you're going to observe. So right now we are only interested in x and z, right? You are only interested in x and z. Okay, so our z is actually negative 1 to 7, like that. Okay, so now let's show our x and z. So our x is starting from, so here we have our negative 1a, and then on the positive side we're going to have 5a and 7a. Now let's show first our x. So our x is starting from here, and it is not going to be shaded, and it is going up to where? Yeah, it is going up to 5, right? It's going up to 5, so we move up to 5a. Okay, and it is not going to be shaded. So we have just showed our x. Let's find now our z. Right now we are just trying to show the x intersection z, where the intersection is going to happen. So now let's show our y, I mean our z, from negative, the same negative here, but this time it will be shaded. Okay, so for z, negative is part of the set, but for x, this negative is not part of the set. Okay, so you're going to say it is moving from -1 to 7, right? So you brought up to 7, which is right here, and it is not going to be shaded. Now, where can you find a region where both x and y has passed, or where you can find the numbers that can be found in the x and z? It is this region here at the middle. Okay, so this is the region where you're going to find all the elements, I mean the elements that are going to be found in both the z, this is z here, and the x. Okay, so it is, I mean, this region here, not where I wished, this region. Okay, so it is this region where you're going to find um where you're going to find the intersection of x and z. Okay, I hope it is making sense. So this is where you have x intersection z. Now if we're to represent this using the interval, how can you write it? So the region is starting from here, right, at -1. Now we need the elements that are going to be found in both. When you look at this negative here, it is not found in it is not in x, it is only in z. Okay, because this is not part of set x, it is only part of set b. So you're going to write -1 with the parenthesis. Okay, don't use this. Okay, if you use this, meaning that you say that this negative is also part of x, but it is not part of x, it is only part of z. Now we want the one that is in both. That's what it means when you say intersection. So you're going to say -1, not this one here. So starting from -1 up to here. Okay, here, which is -5, I mean +5, right? +5 parenthesis. So you use the parenthesis. So you use the parenthesis. So now, right now, you found your x intersection z. So step by step, don't complicate things. You get confused. Okay, you get confused. Don't try to put like everything on one. On one number line. Oh yeah, the answers will come out, but for your convenient purposes, it might confuse you eventually. Okay, so now here's what you do. So now you're going to put now this alone. Okay, this now you're going to put it alone so that you find now its complement, x intersection z. Remember, we are looking for now the complement of this one. And don't forget, just because I haven't showed the universal set, behind the scenes I'm considering it. If I was in a case where anything going beyond this area, I would have considered my -9 here and here my +9. Okay, so first let me just show x intersection z on the number line. A, the universal set, remember that it is containing all the elements. Okay, as you can see, all the elements of the sets are just in between the universal set. So let's show now this on the number line. So I'm going to draw again. Okay, so now you draw your number line. So here I just put my 0 here to just separate the negatives and the positives. So here I'll write -1, and here I'll write 5. Okay, and then I'll consider this is set A. It is found in all the number line that should be drawn. The interval should be considered. Okay, I mean the universal set should be considered. So the universal set is starting from -9 up to +9. Okay, and it is not shaded. If you want, you can also show it. Okay, I'm just using a free and that's why it's not very neat. So this is my okay. So this is set A. It's just showing like where the the numbers are adding up to. Now let's show this one on the interval, the x intersection z. It is starting from negative, right? Not shaded, and up to 5, right? Also, it's not gonna be shaded. Now let me draw a straight line. Okay, so this is my z. This is my x intersection z. Okay, this one here. Now we know that our x intersection z is this one. Okay, now where can I find my the complement? So anything that is between a is found in the x intersection of x and z. Now we want those that are not found a. Where can we find them? It is starting from a, right? Starting from a, going up, going this side, right? Even a starting from a, going this side, right? Is the only place where you're not going to find. Is the only place where you're not going to find what is found a between this region from -1 to 5 is representing this. Now we want those that are not found in this one. It is starting from a going up to this side, right? Even from a going up to this side. Now where are we going to end from? We are going to end from where we are going to find the coordinate for the universal set. So it is up to a. Even this side, it is up to a. So this is x intersection intersection z complement. Okay, even this side, this is x intersection z complement. This between this one is the x intersection z, but starting from here up to there, it is x intersection z. Now remember the rule. If you draw, when you are finding the complement, when you draw a bubble on top of the one that is not shaded, what you do, you shade, right? So you shade this bubble here. Even here, this is not shaded, you're going to shade it. Okay, so you shade it like this. Okay, so it's going to be shaded. Now we need to now explain this. We need to describe now our x intersection z complement. How can you describe this? So I have two regions which are representing x intersection z complement, right? So you're going to begin from this side to describe. And how do you describe using the interval notation? You're going to say, okay, it is starting from -9. Okay, and it is not shaded, of course. So you're going to say -9 up to where? This is starting from a up to a, right? And this time it is shaded. So you're going to say -1. You use this since it is shaded, right? It is shaded. And then you say now union what? Union, you're uniting with another region which is representing x intersection z. It's like you are mentioning them together. Now the other one is starting from 5. Of course it is shaded. Okay, so you're going to write 5. Since it is shaded, you're going to use this instead of your parentheses. And then you say comma up to where? Up to 9, right? Which is of course not shaded. So you have just described your x intersection z. So this is all you need to know. So the first step, you're going to check, okay, I've been given x intersection z. Now complement. So let me begin by first showing this on the number line. After I show it on the number line, I get the interval notations of the region which is representing this one, which is this one from a to a. Okay, and then you're going to now, if you want, you can do the shortcut. How do you do it? Already you showed it here, right? You're just going to say, okay, now, so since the intersection is from a up to a, so now let me just find now its complement. To find its complement, I'm going to draw another bubble from a up to a. Okay, even this one from a up to a. Okay, since it is on top of the one that is not shaded, I'll shade it. And this one here, this the one that we're considering is we are considering the parenthesis, right? So mean that you're going to consider this one a. So even this one you're going to shade it. But that's why I say that this one will be just confusing you to just doing everything on unless you have understood this topic like very much, or you're very sharp. But if you don't want to be confused, because often you might be maybe stressed while writing the exam. So it's better you do things step by step. So I would recommend you use this approach if you don't want to get confused. Okay, it's better you use this approach if you don't want to get confused. So this is how you do it, and this is your final answer. This is how you describe. You are describing the intervals, the numbers that are representing a certain set. Okay, so this time we have two sets, the one on this side and the other one on the side, and we use union 2 to show two different set or set intervals or regions, if I can say. So this is it for this question. I hope you have understood. Okay. Now let's solve this one. So when you're solving this question, you should be moving step by step. So first you're going to finish this one A, then you come to this part. So what do you have here? Here inside the parentheses, it's like you have one intersection x complement. Okay. So first you're going to deal with this one A, then you come to this one A and Z. So what is your y? Your y is negative 5, 3. I mean they are both good. Okay, and then your x is negative 1, 5. Okay, and then now what is your z? Your z is negative 1, 7, like this. Okay. So now, here's what you do now. So remember that we are first beginning with this one. So I'll show first this I'll show it on the number line. Let me draw my number line. Draw a number line. And then now after you do that, you're now going to say that okay, first we're going to show you your y and x. So first write to 0 a, check your y. Here you're going to have negative 1, you're going to have negative 5, and on the positive part you're going to have 3 there, you're going to have 5 there, and then let's show our y. So our y is starting from this, and it is shaded. It is starting from negative 5 going up to 3 here, and it is also shaded. So our y is here is our y. Okay, and our x is starting from this part here, and it is ending up to 5. So, and it is not shaded, so you have something like this. Okay, so this is your y, this is your x. Okay, so now what are we interested into right now? Let's find the complement of x. The complement of x, what is not found in x, is starting from a, meaning that I'll shade this since it is on top of the bubble that is not shaded. I'll shade it. So anything going this up to, don't forget your universal set is ending up to negative 9. So anything up to negative 9 is your x complement. Okay, even this part A, here you have positive 9. That's for, according to your universal set, and it is not, both are not shaded. So and then starting from here, even this one you shade it since it is on top of a bubble that is not shaded, ending up to positive 9. Okay, so you have two x complements. Okay, so now what do they want? What they want here is that they want you to find the intersection of y and complement of x. You have two complements of x, this one and this one. Now they want you to find that region where you can find the members that are present in the complement of x and y. Where is your y? Your y is from A to A. So where you can find the element that are found in both the complement of x, this side you won't find anything because y hasn't reached this part. So this area A, you won't even look at it. Let's focus on this part A. So when you look at this region A, this region is where you can find what is found in the complement of x, and it is also found in the y. Okay, so how can you describe this region in using intervals? You're going to say, okay, where is it starting from? It is starting from negative 5, right? this region is starting from -5. -5. So you're going to say that since this is shaded, you're going to put this the square bracket. You're going to say -5, comma, where is it ending up to? Up to E. This is where this complement is ending up to, where the y has intervened. So you're going to say that up to -1. Okay, up to -1. And when you look here, it is shaded, right? It is shaded. So you're going to have the square bracket. So right now you have just found your what? You have just found one y intersection x complement. Now you're going to plot this alone. You're going to plot it being intersected to z. So now you're going to find y intersection x complement. Y intersection comes. This we've just found it being intersected with z. You already have the digits. You have the intervals. Now let's now combine these two. I'm going to put this and z on the number line. Right now they're just going to be two things. So you're going to be seeing two lines right now. You're going to see the line for representing this interval and the line representing this interval, which is for this one E. Make sense? I hope it is making sense. Now let's dive and solve the question. Okay, so the key here is to be moving step by step. Don't try to put everything at once. You'll be getting confused. You'll be getting stuck. So move one by one, step by step. Okay, so now let's solve this. How can you solve this? So now let's put this on the number line. Okay, let's put it on the number line. Let's put it on the number line. So let me begin with this one here. So I'll put my 0 here to just separate the negatives and the positives. So what am I having on the positives? I have -1 and I have -5. Don't forget the universal set. Even if you don't put it down on the number line, but just remember it will show you the limit, okay, to prevent you from using infinity unnecessarily. You might get the wrong answer. Okay, so we are ending up to here -9, this side +9. Okay, and they are both not shaded, right? Okay, so let's show now this one. On the positive side, what are we having? We're having even 7, right? So let's show now y intersection x complement. It is starting from 5 here, and it is shaded. Okay, it is going up to where? Up to A. Okay, it's going up to A. So, and it is not shaded. And how about your z? Your z is starting from -1. It is starting from where this is ending. Here we have put -1. Actually, it should be A, but this is -1. So this one, z is starting from A, and it is shaded. Okay, because of this, I'll shade the bubble. And then it is going up to where? It's going up to A. Okay, up to A. So now, they want us to find, where can you find the region where you can find the numbers that are present here, that are present in this region, they are also present in this region. Which part is that? So the answer that you're going to get right now, it won't even be an interval. It will be just A. Okay? It will be just A. So if you want, you can just say -1, because this is the only part where you can find what is found in this region. This actually is x and y intersection x complement. Okay? And this is z. So this region and this region, the only area where you can find where they have something in common, the numbers in common, is this part A. So this is just -1. If you want, you can just say maybe, I don't think there's another way of representing this. Maybe another way, maybe you can just say -1 to -1, but still, you're just saying that it is same as saying this what I've just written here. So this is the final answer. And I hope that you have enjoyed. And for more videos like this, make sure that you subscribe to the YouTube channel. And if you like this video, make sure you click on the thumb up button there and share your opinion in the comment section. and what you think about this video. And for more lessons like this, join my tutorial group. I have a group where you find organized videos, simplified content in mathematics, biology, chemistry, and physics. To join the group, you can contact me. In the group, you can contact me on this line here on WhatsApp. I'll add you to the group on Telegram, or you can contact me using these details on Telegram. I'll add you in my Telegram group. You'll find the video lessons of mathematics. And don't forget to subscribe and share the videos to your friend. And I hope that you have enjoyed. Now you can dive into more questions in the past papers and try to solve them. I hope that you've understood, and if you haven't understood anything, feel free to replay the video, and don't forget to watch the part 1 video. This is part 2 video, and have a very nice day.